Good morning and welcome once again to my living room. Today we are going to talk about lists. So here I just want to show you. So in case you're hearing some noises in the background, I'll just mention that I do have a reef tank in my living room. As you can see here, a few little fishes swimming by. So hopefully that won't be too much of a distraction for you. All right, so what I'm going to do in the lectures is just share my desktop with you and show you my PowerPoints. So hopefully that's going to work. As usual, your PowerPoints are available on Moodle, so you can just upload those and follow along with those if you like, or you can just watch along the video, whatever is going to work best for you. So here, let me just switch over to sharing my desktop. Or I guess this is just my PowerPoints. All right, let's see. Okay, so here we go. Hopefully you can see the PowerPoint slides at this point. Let me just put this in the presentation mode so we can get the best view on those. All right, so here we go. Today we're going to do the lists. So lists have a lot of things in common with what we've talked about in strings, as we're going to see. So that's what we are going to discuss today. So just taking a look at what other topics we have in the course. Today will be lists. Our next lecture will be about dictionaries, which is another data structure, somewhat related to regular dictionaries, as you might expect, and some other things that are different from regular dictionaries. File input and output, which is going to be how you can write data to an output file. And our final substantive topic is going to be classes, objects, and methods, which is basically our brief introduction to object-oriented programming. We will have a second exam in this course. It may not be exactly the same format as the first exam because, as you might imagine, there are some issues with proctoring and so forth. So probably be looking to have something a little bit more open-ended or open book or something along these lines. There'll definitely be more to come on that as I have a little more time to just think about how we can best handle that. So you've had your proposal worksheets due. You should be getting comments back from me actually at the time you're listening to this. Hopefully I've already gotten all of those back to you. What you need to be doing at this point is working on your project. You should have attempted a minimum of 2 or 3 of your topics or areas of focus by the time the project preliminary results are due. So we're going to stay on schedule as much as possible and try to have as much normalcy as we possibly can given our situation here. Okay, and then we will have the final projects due during the final exams week as expected. And of course, you should continue to be reading in your Think Python book, and you can notice that we have our readings listed here on the course calendar. All right, so then moving into a bird's eye view of what we're going to discuss today. First of all, we're going to recall information from strings that's very much related to what we're going to talk about in lists. Slicing and indexing is almost exactly the same. Introduction to lists about definition, usefulness, syntax, what is homogeneity in a list, and list of lists, which is a very useful topic for many of your projects. Tic-tac-toe, Battleship, and many other games that are of a board game kind of a nature. We'll also talk about familiar tasks overloaded for lists, indexing, slicing, addition, repetition, coercion, comparison, len, and in are things that you've all heard of before. We'll also, again, revisit looping. This is something that's going to come up recurrently throughout the course. How do we loop over a particular data structure? So we'll talk about for and while loops. And finally, we'll discuss list mutability. That is the special property of being able to change the things that are in the list, which is something we haven't seen before, because when you have a string, you can reassign it, but we haven't talked about going in and changing a particular position in the variable itself, and that's what mutability is all about. So we'll see that today. So let us begin by recalling information on strings. So this is just a little warm-up exercise recalling strings. So take a look at this, and you certainly can feel free to pause the video if you want to try this out yourself. What will Python return? So here is a string, and I'm asking you to pull out a couple of different slices here and put those all together and see what will happen in 1, 2, and 3. And finally, write a function that will process each character of a string. So I'm thinking about looping of some kind. Think about which loop is the most appropriate kind. Do you need positional information? If it finds a space, it should replace it with an underscore and then return that result. So think about how you think that could best be implemented. All right, feel free to press the pause button right now. And when you rejoin us, we'll talk about my solutions to these problems. All right, so welcome back. This is the answer to the warm-up exercise. Hopefully the first 3 have been really pretty simple. These are the answers here. And taking slices, recall that when you have a colon and nothing after it, it's going to go all the way to the end. This is going to do the indexing, that is taking out a particular position, and this is a range, right? So it starts at 2 and goes up to, but does not include 5. So when we put this together, we get where. And here we have a little interesting phrase that we pull out, so you should be able to pull out clear, clear water from this. Here's the function that I asked you to write, or my solution to that. So space to underscores takes string as an input. Notice we have this input parameter s here. Of course, having good syntax for our function, which includes the signature at the top and a note about what it's going to do. We don't include information about preconditions if there is no precondition other than what it says here. So we're going to begin with an empty accumulator, and here we have a for loop. So here we have for character in string. So if the character is equal to the empty space, what do we want to do? We want to replace it with an underscore. So the accumulator is going to do a plus equal of the underscore. Otherwise, it should just keep the character. So here the accumulator is simply just accumulating the character if it's anything other than a space. And then we return the accumulator to see the whole thing. And so if we then come over here, we see that this is the result that we get when we put in Palm Beach, Florida input. We see that the underscores are added. Excuse me. Okay, so let's actually get into some of the things that are particular to lists. So lists being compared to strings, there's a few things to notice. So they can be manipulated in many ways that are very similar to how strings can be manipulated. They can contain multiple entries, and their elements can be processed in loops, much as we have done string processing in the last section. So we'll be seeing some loops once again. We can also do comparisons, so we'll have if statements involving loops. However, there are 2 important ways that they differ, and that's that the elements of a list do not all have to be of the same type. So if you had a variable, so you had like some variable equals a string, like inside the string, you only get one type. It can only be a string. But lists can have compound types. Not that I'm saying that's a good idea, but you could have integers and strings as the items in your list. Lists are also mutable. That is, the contents can be changed after they are created. So when we've been doing strings, we cannot change what it is other than doing variable reassignment. So mutation is like partial reassignment. It's changing a particular point in the list, and which is different than reassigning the whole thing. So it'll allow you to update the list, maybe add some more things on and so forth. You might say, well, I thought we did do mutation with strings. How does this work? So when we had a string, for example, when we did string processing, we processed it a single character at a time, but we didn't change the string itself. What we usually did is we had it going into an accumulator, and that accumulator was collecting one letter at a time by reassignment. So we had accumulator equals accumulator plus, you know, the letter or whatever it was, which is distinct from mutating the list itself. And that's what we'll see, being able to update an item in the list. So why are lists useful? Let's just preview lists in action to understand what this is. So suppose we wanted to take an average of your test scores, let's say. Well, I'm sure your test scores will all be 100, right? But suppose we had some scores here and we wanted to average them together. So what we have here is a different variable for each of 5 scores that some student received in a class. Okay, and so then we would have the total score is going to be equal to the sum of the 5 scores, and then we would compute the average as the score total divided by 5, which will in fact work to compute the average of these 5 test scores. And then it's going to print out the averages and print that average value. So let's compare and contrast that with another way we could look at this. So with lists, we're going to have a couple of different things that are going to change. So what we have here is we have the definition of a list, which we're going to recognize by having these square brackets. Here we have exactly the same test scores that we've had over here, but instead of being in individual variables for each one, it's a single variable which contains multiple test scores. Then we're going to initialize the score total at 0. And you see here we have a for loop. So we do for score and scores. So you recognize this structure as being some variable, and then you have something that you're looping over. So this is similar to what we've seen before. So for the scores in this list, we are going to compute the total by plus equaling the current value of score. So just like with other for loops, this will take on each individual value of the items in the list. And so therefore the score average then would be the score total divided by the length of the scores. And we could again print out the average. So let's just think about what are the advantages of doing things using a list. So in using a list, one of the reasons why this is so much more advantageous is consider the possibility that there was an extra test score that we didn't think of. Pop test, surprise. So the problem on the left using individual variables for that is that we would have to now define another variable that we didn't anticipate. So we can't do that while the program is running, right? Because you have to stop and you have to add a new variable and then you have to rerun it. And in the case of having a list, well, as it's written, you would also need to go back in and change that. But you could imagine having some sort of interactive thing to add another entry to a list, but you can't add a brand new variable as the program is running. So the advantage is, first of all, the ability to expand. Let's see where that also helps out really well. So comparing on the left, you see that we have our average is divided by, well, is obtained by dividing out by 5, which is a fixed number because we happen to have 5 test scores. But again, suppose we have a 6th one, what are we going to do? It's not going to work. So you have to hard code this into the number of score items that you have. Whereas here, we're able to code it in as the length of the scores list. And so you see that that will automatically update. And so doing this kind of a setup where we can loop over things and do it in a more automated way could be advantageous in many situations and why we might choose to use lists instead of having individual variables. So let's just get a little bit into the syntax here. So first we're going to enclose a list in the square brackets, as you've noticed in the examples we've seen so far today, and separate the elements by a comma. An empty list is just the square brackets. So just like we've had empty quotes and zeroing things out. So an integer having nothing in it is 0. A string having nothing in it is the empty quotes, and an empty list is the square brackets. The index of the items in the list is going to begin at 0, just like it does when we index the strings. So here is an example of how you can set up a list. So again, just recall, we don't actually type the angle brackets, right? So you're going to make some name for your list, a variable name, which will follow the variable names we've been doing all along, equals square brackets are mandatory. And so what you're going to do is you're going to have your list elements, however many you have, and and that's what it will look like. So here is the list containing 3 integers. So this has 1, 2, 3. You press enter, it's of course interactive, and you get 1, 2, 3 back. Here we have a list that we've actually named. So the list A, this is variable assignment. A is a variable which is equal to a list. So the type of A is list. This contains 3 strings. The strings happen to be the letters A, B, and C. So if we type A, this is what we get. Oops. The list called B contains 3 strings, which all happen to begin with the letter B. Here we go. You see that what's interesting about this is the entries of the list are longer than 1 character long. So the positions in a string, of course, were the individual letters. So the length of that variable as it's indexing over is always going to be 1 because it's only a single character. Whereas here, if we're looping over a list, each item in the list is that whole thing. So it doesn't index like BOB, right? It indexes like this is the 0th element, this is the first element, second element, and so on. The list called prices contains 3 floats. So here's 3 floating numbers, and we can type prices and see the values in that list. As you might expect, the types of the items in the list to follow the types that we've had so far. So we can identify these as integers because they don't have a decimal value. These we identify as strings because they have the quotes on them. And again, this is another string, which happened to be longer than 1. And here are the floats, which we recognize because they have the decimal point in them. So lists have the type of list themselves, but they also have types of the items in them. And we'll see that when we actually start to write our signatures on functions that are working on lists, because we'll specify the type list, and then we'll also specify the type of the items in the list. So that brings us to homogeneity. A homogeneous list means that all the elements in the list have the same type, but it's not necessary to have everything have the same type. We could also have an inhomogeneous list, which happens to have elements that are of a different mixed type. And I need to plug in, so I'm going to pause you for a second. All right, let's see. All right. All right, I think we're back to sharing. Let's see, pause share. Sorry for the confusion here. All right, so can you see me? Your screen sharing is paused. Here, we're gonna just stop the screen sharing. Okay, now let's get back here. So sorry, guys. Let me see. Share screen, and let's go back to the PowerPoints. All right, and can we go full screen mode? Slideshow, there we go. Okay, I think we're back. All right, so homogeneous lists, all the elements are the same. Inhomogeneous lists, elements in the list are not all the same type. So inhomogeneous lists are possible, but just because something's possible doesn't mean it's a good thing to do. So they're generally not practical. Now, there are certain instances when you might want to do it. However, generally speaking, let's keep the list to be homogeneous types. So in this course, we should really restrict ourselves to homogeneous. So here are some examples. So here's alpha equals ABC, all elements of type string. Here's ints, all elements of type ints. Floats, these are all representing floats. Notice there are 1, 2, 3 entries because these will resolve. So as Python converts things to values, notice that it will in fact not save 4.3 plus 7.9, but will resolve that into the sum. Okay, this is an inhomogeneous list because we have a float, a string, and an integer So that's inhomogeneous because they're all mixed. And so lists can be inputs for functions, and the type of list is list, as we've mentioned. So in the signature, the type of the element in the list should be specified parenthetically after the list. So here we can do signature list, and then we're going to tell what the type inside the list is. So this one could either be float or int, so we're going to indicate that by float or int, and the output is going to be floats. This is going to add the numbers in a list as floats. If empty, it's going to return 0 because of the accumulator here beginning at 0. So here's our accumulator, and we do for a number in nuns, so for loop, the accumulator is going to do a plus equal with a float of number and return accumulator. So this will basically take the sum. So if we add up 1, 2, 3, then we get 6. This would also process lists of strings. So remember that we have overloading. So here is an example where we have list of string items, which will give back a string. And so the major difference is the accumulator is equal to the empty quotes as opposed to being 0. So for string and strings, we're going to augment the assignment, and then we're going to return the accumulator. So we get ABC all concatenated together when we sent up a list of individual characters. Okay, list of lists. This is a really useful thing for many of your projects, as I mentioned earlier on. So the elements of a list could be a list. So why stop at only having one list? You could have a list inside of a list. And so this is actually a common theme that we're going to have throughout Python, is having a type and then putting some type inside of another type to build up more complex ways of representing information. So here is an example of a list having is the first element a list, second element is another list, and here's a third element is another list. And each of these lists then have their respective elements in it. So the 0th element of my list, so here I'm pulling out, we'll talk about syntax in a moment, but here we're going to pull out the 0th order, and you can see that that is this right here. It's ABC, right? It pulls out a whole nother list. And the second element of my list is going to be similarly selected. So here is that. But suppose you wanted to pull out an item inside an item that is effectively making selections of individual item. This comes in really handy when you're trying to represent boards. So like for your games, this comes into play for Battleship. You can do tic-tac-toe this way, and Connect 4 and many other games that you've proposed. So anything that basically has a board game where having an X and a Y coordinate, this would be a great way to consider having it set up. So here we consider a Battleship board where we have columns labeled 1 through 6, and the rows are going to be labeled ABC. So you see that we could give a coordinate. So let's say we wanted the coordinate of H, this would be B2. And so how could we represent this as a list of lists in order to pull that out? So what we're going to do is we're going to make a representation of each of the rows. So consider that row A has 1, 2, 3, 4, 5, 6 empty spots. So here it's 6 empty spots up here. And so this is the 0th row. So these numbers are just the number on the board, the labeling. Okay, so it says A here, but we need to keep in mind 0 because that would be our 0th order element. And then here we have ships spelling out the location of this battleship sitting on the board so we can keep track of the positions. So you're going to represent that as SHIP and then 2 dots for the empty spaces there. And then again, we're going to have 6 empty spaces for this row down here. And I've also got them indexed down here for you as well. So it's indexed up just like the board. So how could we do that representation? So here we go. Here's game, which will represent our board, is equal to a list of lists. So here I represented the list of lists for the whole board. And inside that list, each of these items, being a list, has the characters that are here. So our first one is going to match up to this first row here, which is this representation here. Our second one, which is index of 1, will say ship with 2 dots to represent this, as we've put up here. And finally, we'll have another row of dots. So now suppose you want to pull out a row where the ship is located. So if we pull out game of 1 being the So remember 0, 1, right? So this will pull out this whole row. But suppose you wanted to pull out the individual position S. So what we're going to do is we're going to pull out the first row, and then out of that, we're going to pull out the 0th item. So what we get is 0 row, 1 row. Oh, yeah, this is our row. And then we want to pull out the 0th item within this row. Well, the 0th item in this row is S, which we also can see from here. So this returns only the letter S. And similarly, we can then pull out each of the individual positions in here. And of course, we can index any of the other positions here as well. But this should give you the idea as to how you can use double indexing. So this will be the index of the row, and this will be the index of the column in order to pull something out on a board. Familiar tasks overloaded for lists. So there's a number of things we've already learned how to do using strings that are overloaded for lists. So we can do indexing and slicing. So we've seen that with strings, and how it works with lists is very similar. So here's our indexing syntax. We have a list, and then we have our square bracket, which innocently looks like just little square brackets like you might have for parentheses, but in fact, they're an operator. So don't forget that. It's an operator there, and those operators are going to tell you which position you're going to pull out. So let's take a look. Here's a list called cities, which has these 3 city names, the places where you might want to take a nice spring break vacation. Or maybe you've just come back from one of these nice places. So what we're going to do is here we can do cities of 0, and that will pull out the 0th item. And cities of -2, so just like we talked about doing the positive indexing, we also have negative indexing. Remember, in the reverse direction, it doesn't have a 0 because you can't have positive and negative 0. There's only just 0. So we have -1 is Boca Raton, and so -2 is going to be Orlando, which we see here. And here is the numbering just put down here for your reference. So we have 0, 1, 2, and then it goes up to 3, which is not actually a position in the list, but you go up to but not including, and that represents the length of the list. And then we go in the backward indexing to use when we're using the negative numbers. So indexing is to pull out an individual position. Slicing looks remarkably like it, but the way we notice that it's different is that it has this little colon right here. And so this colon then is going to allow us to specify a range. Just like we've had before, if you omit the start index and you have the colon, it will begin at the beginning. And if you omit the end index, it will go to the end. So here's some examples. So cities of 0 to 2 goes up to, but does not include number 2. So we go 0, up to, but not including 2. So we get Tampa and Orlando. Cities 0 to 3 then includes an additional city. This starts at the beginning because nothing is specified. This uses, okay, so this is an interesting example. So we're starting at number 2, right, -2, and we're going down to 0. So if you index in the backwards direction, you're always going to get the empty string, even if it's non-zero, like you think that there's something in there, because between -2 and 0, there's a difference, right? There should be some content, but whenever you're going from the right to the left, whether you're using positive or negative indexing, that's how you get the empty brackets. It's the same with the strings. So always have to index in the forward direction. And so what you might have been expecting is -2 at the end, which is Orlando and Boca Raton. So even though this starts with -2, you can go to the right because it goes up. So that's fine, left to right. List addition and repetition. So the plus and for concatenation and the star for repetition operators are overloaded for lists. So that means you can use them on lists, and we'll do something related to what you've already learned about them. So concatenation syntax would be a list 1 plus a list 2. And the repetition syntax is going to be list 1 times an integer. So notice that this is times an int. These both are the same type, but this is not, because you need to say how many times you want to multiply it. So here's some examples. Here are 2 lists being added together, and you see that the 2 lists basically just join together. Notice that it's not a list inside of a list as maybe you thought would happen, but actually it just, all the items go into a single list. This is going to be repetition, where we multiply the list but 2 times. So we're going to have 1, 2, 3, 1, 2, 3. So we just multiply that 2 times and it all goes into one list. And here's an example of a list with some strings in it, and that's going to be multiplied by 2. And here's the result. The list coercion function can be really useful. So the list function can be used to generate a list out of a string. So for example, if you're lazy, as all computer scientists are, they don't like to do any extra typing. So what we can do is we can do the list coercion and then give it a string. Notice we have these round brackets, parentheses, which are part of the syntax that we use in order to tell it what it should do. So if we do list of Fort Lauderdale, we see that it breaks it out into a list where every item in the string is going to be an individual item in a list. List comparisons, so the comparison operators that we've seen before, less than, greater than equal to, or less than equal to, are overloaded for lists to do comparisons of the lists. So a Boolean is returned based on the element pairwise comparison, so we're expecting true and false. And so for pairwise comparison, recall that capital letters go before lowercase, and all of that is still going to apply. So basically what's going to happen is we're going to compare the items in list 1 and list 2. Again, we should think of these as comes before for less than or comes after for greater than to help us understand how this would go. So here is a list of 2 integers and another list of 2 integers. So what we would do then is we would ask, okay, so does 0 come before 0? Well, we can't decide because it's the same. So we move to the second item in the list. Does 0 come before 1? Well, it does, yes. So the answer is true. And so then we're going to do our next comparison. And again, we cannot make a decision on the first one. So we move to the second position. And so is 5 coming after 7? No, that's false. So that's why we get false back. Now we're going to start doing some comparisons on some characters. So again, remember that the capitals precede the lowercase. So we look at, and we're going to then do string comparisons. So we're going to say, does zoo come before aardvark? And in fact, we can already make a comparison here and make a decision because Z comes before A. So zoo comes before aardvark, and that means this whole list will come before this whole other list. And so the answer will be true. Okay, and here's another example here where lion is the same in both, so we need to default to the next position. So we're going to compare tiger and monkey, and tiger beginning with lowercase t does in fact actually come after M in monkey, so that will be true. Length, which we have seen before, can be used on lists similar to how it's used on strings. It will report back how many items is in the list. And here is our syntax. We have length and then the list. So for example, here's cities, a list, and we ask what's the length, and it tells us it's 6. Be an operator can be used on lists similar to how it's used on strings. It's going to return a Boolean to indicate if the query is in the list. So we're going to set this up like this. We have a sum query in the list. So for example, here is a list of some cities, and we ask the question, is the string Miami in my list? And it comes back true because it's right here. Notice that if we had left the quotes off, that would be an undefined variable, and so that would have caused a problem. Let's ask, is Boston in my list? No, it's not, false. And we can ask, is Clear in my list? So you might say, oh, look, it's right there, I see it. But it only is going to tell if the whole thing, if it's an exact match for an item in the list, is in the list, not if it's inside the item in the list. So even though Clear does appear here, it will be false. So that brings us then to looping over lists. So you might have been expecting that we're going to have this, and we've previewed those in a few examples that we've seen so far. So we have for loops, we have range, which is basically a kind of a for loop. And we also have while loops. So for loops and lists. So for can be used with lists. The loop variable is assigned to each element in list in turn. So we're going to have the keyword for, then you're going to pick a variable name, and then you're going to have the keyword in, and then you'll provide a list. So the variable will implicitly be assigned to each of the items in the list in turn, and then whatever you want to do in the body of the loop. So here's an example. Here's cities. And what we're going to do is for city in cities. And then we're going to print out this cute little advertisement for that particular city. So when we run this, what's going to happen is we will print out visit sunny Miami, because for city will equal the first item in the list, Miami, and then it will substitute in the print statement. Visit sunny city, what's the value? It's currently at Miami in the Sunshine State. And then we do Ocala, Daytona, and so forth to cycle through all of the cities that we've had in our list. So now let's get back to that computing the average score. We saw a preview of this earlier in the talk. And so now we are ready to take a look at this. So similar to the program that we previewed, what I want you to do is write a function that computes the average of some test scores. So you've seen a preview of how this is done, but now I want you to try to do it. So the function should output a float, and here's some starter code where I've defined a function. Note that I have given you a signature here, and what should it do? So here's some test scores, and it should print out your average score is, and then it should compute this. So here is an example of what the output ought to look at. So why don't you go ahead and just pause this video and take a moment to see if you can now write that now that we've seen the for loops. All right, so welcome back. What we see here is a possible solution to the average score with lists. So what we have here is score total being set to 0 as an initialization. Now we have a for loop, and we chose to use for because we can process each item as we see it. We don't need to worry about the test score after or before it, and we don't know specifically what range it would be, so a for loop is going to be a really good choice for this, because we're going to process each one in turn and do something with that particular score that we're on in the loop at that time. So here we go. So for score and scores, we're going to say that the score total is going to be equal to the current value of the score plus the new one. So that will sum them all up. Then outside of the for loop, we're going to compute the average. So notice that we don't have the average inside the for loop. The average needs to be done at the end. So the total, after we've summed them all up, then will be divided by the length of the scores. That's how we're going to get the average, right? You take the total divided by the total number, and then we will return the score average. So here's the test scores, and here's my statement that also has a function call inside of it, and notice that it also is sending up an input parameter, the test scores, which is this list. Again, just notice that the number of parameters here in the function is 1, and this is 1 here. So you might say, oh no, it's not, it's multiple. There's how much? 3, 4, 5 test scores here. So how can we send in 5 things with only 1 input variable? So that's a great question, and the answer to that is that being a list, the list itself is only one thing, and that's why it's considered just one thing, and you can pass that in. Notice that also we would have the possibility to return an entire list, which could contain several items, but in fact is only a single entity. Because of course with returning, we can only return a single entity. Input parameters, we could in fact make more of them if we wanted to have more than one input parameter. All right, so here's another exercise with for loops and lists. Write a function that determines which city in a list of cities has the longest name, or declare that at least a two-way tie occurred. The function should return either with the name of the longest city or the word tie. 2 test lists are given. All right, so let's just talk about the expectation here. So Orlando is clearly longer than Tampa, so we would expect our function to return Orlando. But here, 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. I think 2 of these should be the same lengths. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So Orleans and Orlando are the same length. So we have a tie situation here. So why don't, oops. Not giving away the answers just yet. All right, why don't you go ahead and pause the video and see if you can write that function yourself, and we will reconvene and then chat about how I chose to solve this problem. All right, so welcome back. This is the way that I solved the program get longest city according to the inputs that we had. So what I'm going to do here is I'm going to set longest is equal to 0. So I'm going to initialize that counter to 0. And now what I'm going to do is I'm going to cycle over the input cities. So for city and cities, if the length of the city is greater than the longest, then that means that I have a new longest city. So the longest is going to update to the length of the city. Now notice that this is going to be the length, right? So you might think about writing out your variable table and keeping track of your types. Now what we're going to look at over here is then the longest city is equal to city. So we have longest keeping track of the longest length and longest city now being equal to the actual name of the city. So if the city is the longest, the new longest city, we will update these two variables. And if it's not, then the length of the city is equal to the longest. So this means we have the tie situation, in which case we would change the name of long city to tie. We don't need to update longest because it's the same. We just established that right here. But we would set this equal to tie because we're supposed to report back the word tie instead of the city name in the case that it is the longest one. So it's going to cycle through this whole list and pick out which one is the longest, and then we're going to return long city. So let's just see how that would work as we step through for Orlando and Tampa and our cities one list. So here's Python, runs and says, oh, I'm going to learn how to do get longest, but I'm not going to run yet. Just learn how to do it. Oh, let's see, here's a list, and here's another list, and now I'm going to print something. Oh, but I have a function call here, so let me go do whatever this function says. So I'm going to run my get longest, this function up here, and I'm going to send up the value of cities1, which happens to be a list containing Orlando and Tampa. So that goes up here, and we have the variable assignment of cities to Orlando and Tampa. Notice again that just like we've seen before, the name of the variable that's sent up does not have to equal the name of the variable up here. So because it's a variable assignment and only the values go here. So this is what we're going to do. Longest equals 0. So for city and cities, if the length of city, so what's the current city? It's Orlando, is greater than the longest. Well, of course it is. We haven't seen any. The longest is going to be equal to the length of the city. So Orlando, O-R-L-A-N-D-O, 5, 6, 7. Okay, so now longest is going to equal 7, and the long city is going to be equal to the city, and our current city is Orlando. So then elif doesn't happen. So do we return yet? No, it goes through again because we're still in the loop. Do we have another city? So now we have Tampa. So the length of Tampa is only 5, which is not as long as Orlando. So this isn't true. So then we're going to check if the length of the city is equal to the longest, which it's not, it's shorter. So nothing happens and there's no specific branch to handle it. We could of course have else pass, but that would be a little bit redundant. I mean, what would the point of that be? So we just don't do anything by not having a branch there. So then what we do is we've completed the list. So now we're going to return long city, which is going to be Orlando. And we see here, ta-da, we got it right. Now in cities 2, we're going to put it in and it's going to process. So Tampa is first, which is the shortest one. So initially, the length of the city will be 5 and the city that will be assigned will be Tampa. But once we get to Orlando, it's going to overwrite. So then what's going to happen is Orlando, being longer at 7, will be used to overwrite this data here. So the longest will go from 5 to 7 and long city, the actual name of the city, will become Orlando. And so elif doesn't apply. But now I go through with Orleans, which is the same length as Orlando. So if the length of the city is greater than longest? No, it's not. If the length of the city equals the longest? Yes, it does. Now we're going to assign it to be a tie. So the long city name will update from Orlando to tie, and the longest is still the same at 7. And so when we return the long city, we will then get back the word tie because we updated it because of this elif branch right here. So that's how that works. Hopefully that's reasonably straightforward and you can figure that out, and hopefully you were able to write something similar to that. Okay, range and for loops. We can also use range to automatically count up to, but not including a specific value. You can also count down, which is used with negative numbers, but essentially we can think about it in the positive direction. It's negative basically works the same way. So we have 4 variable in range, and then we're going to have an integer here, and then we'd have the body. So if we say for I in range 3, print I, you see that I is going to increment from 0 to 1 to 2. So if we have my list is equal to ship, and we have for I in range length of my list, you see that it will cycle through and print out one value of I for each item in ship. So that's how you would set up a range loop using a list, well, using a string. And we can do similar things with lists. All right, so while loops and lists, so we can have a while loop to use with lists, such as they are used with the strings in an explicit variable, incremented by a counter, and can be used to loop over the list. So this is how this would look. We would have a variable equals 0 for initialization. Then we have our while variable is less than the length of the list, colon, and then we have our loop body, whatever it is you want to do, and then you're going to increment your variable. So of course there could be some variation in this, like maybe you wanted to do every other, and so you would do plus equals 2. Or maybe you don't want to initialize at 0. Maybe you're talking about some principal value, or you have some money in the bank and you're going to add more from your paychecks. So these things are suggestions as to how one would normally set up the while loop, but don't think that this is necessarily fixed for all possible while loops. So it's basically an idiom, but will probably work for most things that you want to do. So that brings us to list mutability and aliasing, which is something that we haven't talked about before for strings. What we're going to talk about is assignment versus mutation, and aliasing and mutability. So assignment versus mutation, the contents of lists can be mutated after they are created. That is, they can be changed after you create them. And this is different from assignment and reassignment, because assignment and reassignment overwrite the whole thing, whereas mutation means it goes in and it's going to change a particular part of the list, not rewrite the entire list. So here is something called zoo, which has a lion and a tiger in it. This is a variable assignment, just like we talked about in the second lecture way back in the beginning. So here we have zoo equals elephant, zebra, and kangaroo. So now it has new values, but that didn't happen because we changed these values. It happened because we overwrote everything. So that's a reassignment. But what if you wanted to change a specific element or elements in the list? That's mutation, and we can use the index assignment or slice assignment to do that. So list mutation with an index assignment looks like this. Unlike strings, the lists are able to be mutated after they are created. That is, they can be changed. We use the index assignment to mutate the list such that the value of an element of a list is given as the indicated index is changed. So here we have a list and we give an index, and then we're going to provide it with a new element, and so you can add it in. So here's an example. Here's some cities. We have 3 cities here. And now what I'm going to do is I'm going to change item at index 1. So that used to be Tampa, and now I'm saying overwrite only just element number 1 to Fort Lauderdale. And so then when we look at our cities, we see that Tampa has now been mutated to Fort Lauderdale. That's different than rewriting the whole list. We've only rewritten one position in the list. We can also do slice assignments. So why stop at only changing one at a time? So this means that we can in fact actually change the length of the list. So slice can be cut out and replaced by new entries using the slice operator, which, as you might recall, looks very much like just the index operator, except that it's got the colon inside of it, square brackets. The length of what is spliced out does not need to be the same as the length of what is spliced in. So that's how we could possibly change the length of our list. So here we have list, and then we're going to have our start index, colon, stop index, again, go up to but not include, and then we are going to use the splice list. So notice that the difference here is that we're doing indexing. The type of what we're going to index will need to be a single entry, but this will in fact need to be a list. So the type is not the same. So here we have some cities, Key West, Fort Lauderdale, and Clearwater, and we are going to have cities from 0 to 2. So city 0, 1, and up to but not including 2, so that's selecting Key West and Fort Lauderdale, is equal to this big long list here: Miami, Daytona, Tallahassee, and Pensacola. So when we now look at cities, and we've had this slice operator doing a replacement, a mutation in that list, we now have all the new ones, because we asked it to start at 0 and up to 2. This will go in first. And then what we pick up Clearwater, which isn't in this one. That was left over from here because we went up to, but not including 2. So that's spliced in this new list to replace items 0 to 2. What is an alias? So let's just foray for a moment into something that you might have learned about from popular culture. This is Al Capone. He is a notorious gangster from Chicago, Illinois. I actually used to live in Chicago. And he also had some other names that he was known by, because, you know, if you're a notorious gangster, you might need to have a nickname. So he did, and he had several. So we have Al, Scarface, and Albert Costa were all other names that he went by on the streets, so they wouldn't know who Al Capone really was. So we look at the dictionary definition of an alias. It's a false or assumed identity, a spy operating under the alias of Barsad. And so we also have some other synonyms here to give you an idea. So basically an alias means something known by another name. And we have a similar thing going on in Python. Probably not any gangsters, but we do have aliasing going on in Python. So an alias in Python is a variable that points to existing data. It's a second or more variable pointing to the self-same data. So it looks like this. If we have variable 1 equals some value, and then we have variable 2 equals variable 1, you see that it will have the same value as variable 1, but instead of pointing directly to the value data, it's pointing to the name of the variable. Okay, so this is distinct from the other possibility that they would both point to the same variable. So let's see how creating an alias would work. So if we have cities equals Miami, Tampa, and Clearwater, and cities 2 equals cities, you see that now we have two things that point to the same thing. So you have cities and city 2, both points to the same data. So if things are pointing to the same data and that original data gets changed, then when we ask what is the value of each of those aliases, they will both report back the same thing. But if they're in fact pointing to different data, then what will happen is you can update them independently. And so by changing one, you wouldn't change the other. That's the idea behind aliasing. So when you create that alias, that is when you have something equaling to the value of the other variable, they both end up pointing to the same data. So by mutating that single data, both of them get updated. So let's see how that might work. So aliasing happens when two variables refer to the same list. So both variables point to the exact same list. Aliasing has occurred. That's how we recognize it. So here we're going to create an alias. So here's cities and our list. And cities 2 equals cities. So what happens is this points now to exactly the same data that cities points to. And we can represent that diagrammatically by having a list. Here's our list. And cities points to it. And because cities 2 equals cities 2 points to the same thing, whatever cities points to. I'm going to point to it too. That's what it does. So now both of them point to the same list. So each variable points to its own copy of the list is something different. So here we have cities is equal to this list, and cities 2 equals a list that just so happens to have all of the same items in it, but that doesn't mean it's the exact same list. So in this first case, both of them are pointing to the same list, whereas these two are pointing to distinct lists which so happen to have the same entries. So we can diagrammatically represent that by having cities pointing to one copy of the list and cities 2 points to another copy of the list. So here is a little example for you to try out. So consider the following snippet of code. How many copies of the list exist? So here is our little snippet of code right over here. Which lists X, Y, or Z point to which one? Draw the diagram to show it. And what will the list X, Y, and Z be after the mutation? So do you see the mutation right here? Y of 1 equals 0. What will these be? So let's take a moment, go ahead and pause the video and try that problem out for yourself. And after you've had a go at it, let's return back. All right, so welcome back. I hope you had a fun time testing out that problem. Good idea to try it on paper. Of course, you can try it out in Python as well, but it's always good to get in the habit of practicing on paper because that, of course, can be much more challenging. All right, so let's see what's going on here. We have x is equal to a list called 1, 2, 3. So let's put our list 1, 2, 3 and put x and draw an arrow to it. And now y equals x. That right there is where the alias is occurring. So y is equal to x. Y says, I'll point to whatever x points to. There it is. So they point to the same thing. And then z is equal to an independent list, which so happens to have the same values 1, 2, 3. So this is a new list, 1, 2, 3, and z is pointing to that new list. Now we're going to mutate y of 1 equals 0. So y of the 1th position, this right here, the digit 2, is going to equal to 0. So this is going to update and have a 0 in it. And now if I ask x, what does your list look like? Like, well, I'm pointing to the same thing as y. It's got a 0 in it now. And so there we have it. X is equal to 0, 1, 0, 3, just as y does, because y had the mutations. We expected this one. It's this one that you may not have expected, because this happened in the aliasing. And this is what we're saying about mutating a particular position. When we have aliasing, both of them update. But z being independent, when we ask z, what's your list look like? Z's list being independent did not update. So this is how we have our diagram right here, and this is how this turns out as we do that mutation involving aliasing and not aliasing. So let's take a look at a while loop example with mutability. So here we have a function called a treasure hunt. And you might want to just take a moment to pause and read through this for yourself. And we're going to talk through this. So what we have here is we have a function called treasure hunt that has 2 inputs. It has my list and new word. So let's try to understand what this function is doing. So here we have a signature up here that's going to give us some clues. So the types are going to be a list, okay? And we're going to have a string. So the string will be the new word, and it's going to give back a list. Let's see what it's supposed to do. It's going to search for the string treasure, the exact match treasure, within the words in my list, and it's going to mutate that position into a new word. Okay, so now what we're going to do is we're going to have a while loop, and we're going to have this set to 0. And as a typical thing, we want to have I equals 0, so our counter begins at 0. And so this is really, we should be calling this an index, because it's going to index over each of the positions in the list. So here what we have is we have, looks like I get my pointer back, we have a while list, and that is going to go from I up to the length of the list. And so that will cycle over the list. So now look at this, something kind of clever has been done here. So this is going to check if the word treasure is in my list of I. So that actually is going to pull out an individual item in the list, and it's going to use in for that. So we don't actually have to have an exact word match inside of the list, because it's going to be looking inside the particular position. So now it's a string comparison. So my list of I equals new word. So if treasure is in my list, it will do a reassignment at this position. So we're going to have a mutation, and then it will return the whole list. So you might say, oh, but we didn't process all of the positions in the list. So what this will do is this will process the first instance of treasure in the list, and then it's going to then return the whole list. But because the whole list already exists and we have mutation, and it's not being done by an accumulator, then we will in fact get a list back. So let's see how it would work in a second. So we also just wanted to follow up to say that our counter I plus equals 1 is going to be what will cycle over everything. And because we have the situation where we're going through, and if we don't hit the return, that means it wasn't found in there, right? So if it did find it, it will update and return. But if that never happened, it will be able to complete, and then it will go to the return. So it will return -1, which takes care of the situation where it would return -1 for it not finding anything. Okay, so here is a list called Wisdom. A treasured memory is the fruit of time well spent. Great thought for the day. So here what we're going to do is now we're going to have a modified message. So we're going to run our function treasure hunt using the list wisdom, and we are going to change it to cherished if found. So this is the new word. So here we go. When we send this up, what's going to happen is we're going to search in the length of my list, which is this wisdom. With each of these items, each of these words, going to be an item in the list. So what we see here is if treasure in my list of I. So this is what I was saying about it being a match using string searching, which is going to be different than doing a search in the list. So if we said treasure in wisdom, it would come back as false because treasure is not the same as treasured, but because we're asking the question, is treasure in treasured? This is now a string search, it will be true. And so because of that, then this statement will be true and the branch will execute, and we're going to replace my list of I by the new word, and that will be cherished. So treasured will be converted to cherished, and when the list gets returned, even though the rest of the positions have not been processed, then it will still have them there because the list got mutated. It's not growing like an accumulator. So here's what happens, and we see that as expected, we get a cherished memory is the fruit of time well spent. There's also a number of methods for lists. So we've seen methods for strings, such as upper, lower, is, alpha, is number, which is digit. Yes, is digit. And so we're also going to have some methods that are available for lists, which are very helpful, and there's a number of them. Now, there's, of course, more in existence than we have time to discuss in this class. But this class, you should limit yourself to using the ones that we've talked about, except your final project, where you can have a bit more latitude. But generally speaking, we should work on using the items that we talk about in the class. So let's just take a look at what we have here. So the first one we encounter is append. Append will append one item to the end of a list. So this is what it looks like. You have list.append, and then you have parentheses, and you put your item here. So if you have a list of my list ABC, and you do my list.append, and you put a D here, then your list will have ABCD. Something important to notice is the type of what it is that it takes. So because we're adding a single item, this goes in as a string, right? So this string will be added to the list of strings. Now you could add an integer to an integer list. In fact, you can add any type to any list if you really wanted to, but as we talked about before, creating inhomogeneous lists is definitely not advisable. So notice that this is not a list of length 1. So you might have thought we would put the D in the list by itself, but that's not what we do. We put it in here, and recall that all functions have parentheses, and methods are just an example of a kind of function. We'll have more about that in object-oriented programming, but just think of this as being a function, and functions have parentheses, and so we are going to take as the input to this function the string D, which will be added to the items in this list. Next, we have extend. So extend is going to basically allow you to add more than one thing to the list. So since we have more than one thing, the type of what we're going to add is going to be a list. So again, our syntax is really quite similar, and this is basically how all method notations looks. We have the list dot name of the method, so list dot extend, and then we're going to have the thing we're going to pass to it, which in this case has a type of list, which for our cases really should have the same type as what you already have in the first list. So Python won't enforce that, but you yourself should enforce that because you really don't want to have mixed type lists. So here is an example of extending the list. So we're going to put DEF onto a list ABC, and here is our list. Next, suppose you want to put something in a list and you don't necessarily want to do it at the end. So how could you do that? You can use insert to do that. So what we can do is we can use insert to insert an item into a list at a position specified by an index. Here is our syntax, list.insert. Here is our insert index so that you'll tell the position at which you want to put it, and then you put the item there. So it would look something like this. My list A, B, D. Oh, we forgot C. Do we have to redo the whole thing? No, you don't have to. You could insert a C at position 2. So remember, how do we arrive at 2? 0, 1. And so the 2 will say, this is the position where we want to put it, and it will put it to the left of that and move this over. So we can then put this in just like this. So this is how it will add it in. Note again that we are not having a whole list here, but that the type is a single string. So you could insert a string of more than length 1. You could insert any string. You could insert an integer. You could insert a float. But whatever you put here in this position inside these parentheses is the item that will be inserted at the position here, and the list, this here has to be a list. So here's list ABCD, and at position 0, which is the beginning, we're going to insert the greater than sign. This is really useful if you do bioinformatics. This will convert your file into FASTA format. Ta-da, you can now do bioinformatics. So pre-processing automated. So here we go. We're going to insert the greater than sign, and here is a list with a greater than sign at the beginning. My list.insert length of my list. Okay, so look at this. This is a little bit clever. So again, remember that Python is able to resolve things into the value that they represent. So length of my list can be computed to be a particular position, right? So this will then go to the end of the list, and it will insert this here. So this is exemplifying a string that's more than 1 character long. So here we go. We added this to our list, and we have ... z appearing at the end of the list. We also have pop. Pop is really useful for removing an item from a list using an index, and the pop value is returned by the function. Now, this is really useful when you're thinking about pulling cards out of a deck. So anybody who's doing a project involving a deck of cards or something similar, you'll probably be using pop a lot. What you can think of pop as is like, let's draw a card. So you have a deck and you draw a card from that deck. So now that card is popped out of the deck. So the function will then send that value out. So if you have a variable and you make that variable equal to the thing that got popped, then that's how you can get the card. And now that you've popped it, it's not in the deck anymore. So it really is just like removing something from a deck. So the list has to be not empty, because pop won't work because it can't remove something from an empty list. So if no index is specified, you just do pop and you don't tell it anything. It's going to assume to be -1. That is the last item in the list, which you might use to your advantage if you always want to pull the last card out of a deck. So this looks like list.pop, and here's the index. So it would look like this. Here's my list having a series of items in it. Now, you see what I've done here is I've set a variable equal to doing pop. And so what will happen is this will take the 1th item, which is going to be B, right? And it's going to send the value of that out to this variable popped. So it will send the B card into popped. And then when we ask to look at the list, it will be gone. So here it is showing B has been popped off and showing your list with B not in the list anymore. So here's a few more examples using pop. Here's a list. So this right here, my list is, so this is going to break out ABC into the list. So this is the coercion function, right? So here is the list. So my list.pop, I didn't put any index there, so it implies it's going to be -1, the last item. Here's my list showing that the last item was taken off. My list.pop, again, we'll pull off the last one, and now only A is left in the list. My list.pop, we take A off and the list is empty. If we try to run it again, it's not going to work because the list is empty and there's nothing else that can be pulled out of it, so you get an error. We also have remove, which works kind of similar to pop, but has some differences. So you're going to use remove if you want to remove an item from a list by a value selection. So if you know a particular thing, like you want to draw a particular card out of a deck, you want to select a particular thing. It's going to remove the first instance if multiple instances exist. And also it's not going to return anything for you. So if you want to pull it out and then save that value, it's not going to return that value back. But then again, you've selected it by the value, so you kind of already know what it is. So here's list.remove. and a list underscore item. So this means you tell it what you want to pick. So here's my list, and we have all these letters in here. So if we do my list dot remove A, that means we're going to remove this item right here, which happens to be in this position, but it's not looking at positional information. So then if we ask for my list, we see that it's gone, but we don't have a way to like get the A back other than to know that we specified we wanted to remove A. So my list dot remove C is going to remove only the first instance. So notice that C appears multiple times in our original list. So, what's going to happen? Are they all going to disappear? So we have one right here and we have one right there. Are they all going to disappear? The answer is no. The first instance, that is from left to right, of the C will disappear. So I'm going to expect that one's going to be gone. Of course, A is already gone. So here we see we have B, D, E, C is what's left. Split lines is very useful. Split lines method is able to take things and split them apart. So a string can be split into a list of strings, which we've seen using list. Split is a multi-line it splits a multi-line string into a list of lines. So I called it /n is the new line character. So if you do string dot split lines and you give a string, then this is what will happen. So here's some text, line 1, ABC, new line character, line 2, def, blah, blah, blah. Okay, so you see we have this interesting text line here. And so when we're going to do split lines, we see that each time we have this /n, it's going to take and it will make it into a different line, right? And which will be represented as a different item in a list. So here we see that the /n's do not appear in our list. And we see that we get each of our texts here put into a different item in a list in order from left to right. Let's add the split method. So to split a string, you can do this with a specified delimiter using string.split and the parentheses. If no delimiter is specified, it's going to assume white space, which means anything that's not a printing character like return, tab, multiple spaces, anything like that, which will be used by default. So we're going to do string.split, and then we specify a string, and we put a delimiter in if you want to. So that means you could make it split on another character. Now this can be really useful in processing input. So you might split it on semicolons, or you might have some other character that you want to divide things up. So here is my string, Miami, Tampa, and Clearwater, and now this string I'm going to split, and so I'm going to split it on white spaces by using the default, so I didn't tell it anything, and so here it is, it puts the 3 into a list. Now here is a string, and now what I'm going to do is I'm going to split on the comma. So here is my string, and here is my comma, which I'm indicating to split on. And so here is Miami, Tampa, and Clearwater. So something to notice is that when you use this comma explicitly as a delimiter, it's not going to appear in the items that you get back in the list. Whereas when we split on the white space, the commas were preserved, which may be an undesirable effect if you're trying to parse some input data. But using split and split lines, these can be very useful tools for data processing, especially if you have some input data in a particular format and you need to convert it to something else. This can be very powerful. Join is the opposite. Join is going to join a list of strings into a single string with string.join. Okay, so specify a delimiter to include between the joined items. Empty quotes can be used if you don't want any delimiter. So here we're going to do, right, so you have to do the name of a string and then .join, and you put your delimiter in the list. So here's an example, Miami, Tampa, and Clearwater again, and we're going to do string.join, and we're going to use empty quotes, my list, and so it puts them together with no delimiter at all, because those are the empty quotes. So let's start again with a clean empty list, and now we're going to do string.join with a comma, and what will happen is it will put a comma between the items. Notice that it does not include one at the end. So speaking of the end, that concludes our discussion on strings. So let's put all the pieces together and review what we talked about today. So We recalled information on strings, slicing, and indexing that has a lot to do with how lists are also processed. It's useful to review that to call to mind how it works and how we might apply those thoughts to what it is we talked about today. We had an introduction to lists. We talked about definition, usefulness, syntax, homogeneity, and listed lists. We also talked about familiar tasks that are overloaded for lists. So for example, we have indexing and slicing, which work very similarly to how they work for the strings. We also talked about overloading with addition and repetition. We talked about coercion. We talked about comparisons using less than, equal to, greater than, less than, and so forth in order to compare the items in strings. We would compare them pairwise, and we also are sure to recall the fact that uppercase letters come before lowercase, and we'll compare them position-wise until we find something that's different, and then we would make the decision on which one is coming before the other one, or whatever the comparison operator is chosen. Length tells you the length of the list, and in will search for items in a list. We also talked about how to loop over lists. Mainly we discussed the for and while, but we also saw that it's possible to do range, which is another example of a for loop. Finally, we talked about mutability. We talked about the difference between assignment versus mutation, and this is basically the first time we've seen this because we have only been able to use assignment, or we've been able to use an accumulator kind of an approach in order to grow a new version of a particular string, whereas what we've done here is we've actually been able to go in and change the individual item as we're going. We also talked about aliases, which is pointing to the same data using different variables and how that affects which thing is being pointed to. All right, so I hope that has been useful for you to understand how lists work and how they are similar and different to strings. Moving forward, we'll be talking about other data structures such as dictionaries, which will be somewhat related to lists. So what I would recommend you do is move on to trying out the lab at your next convenience, and or whenever we have our meeting online, our Zoom meeting, in order to talk about these things. All right, thanks guys. I hope everything's going well, and we'll see you soon. Bye-bye. Stop share. Stop. Bye.